Welcome to the ultimate guide on acing your data engineering interviews using the STAR technique. Whether you're diving into the data world for the first time or shifting gears from another job role, you're in the right place to transform your interview responses from good to outstanding. Hi there. My name is Priscilla, and I've been where you are, eager to land that dream data engineer role but unsure how to shine in behavioral and situational interviews. Today, I'll walk you through the STAR technique, a powerful method to structure your answers clearly and impressively. Let's decode this secret together. STAR stands for Situation, Task, Action, Result. It's a storytelling framework that helps you share experiences effectively, showing not just what you did, but how you did it and the impact of your actions. Start with the situation. Set the scene for your story. Describe the context within which you performed a task or faced a challenge at work. Remember, details matter, but keep it concise and relevant. Next is the task. Explain the responsibility or challenge you were tasked with. Highlight the goal you needed to achieve. Now, dive into the action. This is where you detail the steps you took to address the task or solve the problem. Focus on what you did, showcasing your skills and initiative. Finally, cap your story with the result. Share the outcome of your actions, including quantifiable achievements and what you learned. This shows the value you brought to the team or project. Let's take a look at some examples of how to use the STAR technique in answering interview questions as an aspiring data engineer. Now, example number 1.
Can you describe a time when you improved the efficiency of an ETL pipeline?
In my previous role, we had an ETL pipeline that was critical for daily reporting but was becoming increasingly slow and unreliable, causing delays in decision-making processes. My task was to analyze and optimize the pipeline to reduce run times and improve data quality without interrupting the daily reporting cycle. I started by conducting a thorough review of the existing pipeline, which was primarily built using Python for scripting and SQL for data extraction. I identified several bottlenecks, including inefficient SQL queries and Python scripts that weren't optimized for performance. To address these issues, I refactored the SQL queries to reduce the amount of data being transferred and rewrote the Python scripts to utilize parallel processing techniques. Additionally, I introduced Apache Spark for data transformation tasks, significantly reducing the processing time by leveraging its in-memory computation capabilities. I used Airflow to orchestrate the pipeline's workflows, ensuring that dependencies were managed more effectively. All changes were version controlled using GitHub and thoroughly tested in a development environment hosted on AWS before being deployed. The optimizations resulted in a 50% reduction in the pipeline's runtime, allowing for more timely and reliable daily reports. The use of Spark and Airflow also improved the scalability and maintainability of the pipeline, enabling the team to easily add new data sources and transformation tasks as needed. This project was a key factor in improving our team's ability to support data-driven decision-making across the company.
Example number 2.
Describe a challenging data integration project you worked on. How did you approach it?
At a previous job, I was tasked with integrating data from several disparate sources, including relational databases, NoSQL databases, and external API, into a cohesive data warehouse solution. The challenge was to design and implement an efficient, scalable ETL pipeline that could handle the diversity of data formats and structures, while ensuring data quality and consistency. I approached this challenge by first conducting a detailed analysis of the data sources to understand their schemas, data formats, and update frequencies. Based on this analysis, I designed a multi-stage ETL pipeline. For data extraction, I used Python scripts leveraging libraries like SQL Alchemy for relational databases and PyMongo for NoSQL databases. To transform the data, I developed a series of Spark jobs that could process the data in a distributed manner, handling the various data formats and performing necessary transformations and data quality checks. The transformed data was then loaded into a data warehouse hosted on AWS Redshift, chosen for its scalability and performance. To orchestrate the entire workflow, I used Airflow, setting up DAG to manage dependencies and scheduling. The project's codebase and documentation were managed on GitHub, ensuring collaboration and version control. This integrated ETL pipeline significantly streamlined our data processing workflows, enabling the ingestion and transformation of data from multiple sources into a format ready for analytics. It led to a 40% reduction in the time analysts and data scientists spend preparing data for analysis, enhancing our overall analytics capabilities. The successful implementation of this project demonstrated the effectiveness of using a combination of Python, Spark, Airflow, and AWS in solving complex data integration challenges.
Example number 3.
How have you used AWS services in your data engineering projects?
In my last role, there was an initiative to migrate our on-premise data infrastructure to the cloud to enhance our data processing capabilities and reduce infrastructure costs. I was responsible for designing and implementing a cloud-based data processing and storage solution using AWS services. After evaluating our needs and AWS offerings, I chose to use Amazon Second 3 as the central data lake storage solution due to its scalability and durability. I designed ETL pipelines using AWS Glue, a serverless data integration service that allowed us to prepare and load data for analytics efficiently. For data processing tasks that required more custom solutions, I utilized AWS Lambda functions written in Python, which provided flexibility and cost efficiency for smaller event-driven processes. To manage the orchestration of these tasks, I implemented AWS step functions to coordinate the Lambda functions and Glue jobs, ensuring a smooth data flow from ingestion to storage. The entire setup was monitored using Amazon CloudWatch, providing visibility into the performance and triggering alerts for any issues. Throughout the project, I used AWS IAM roles and policies to enforce security best practices and data access controls. The migration to AWS significantly improved our data processing speed and reliability, while offering greater flexibility in scaling our operations. The cost of data storage and processing was reduced by 30%, and the team was able to deploy new data pipelines and analytics models more quickly and efficiently than before. This project was pivotal in our transition to a more agile and cost-effective data infrastructure, laying the foundation for further innovations in our data strategy.
These responses highlight the data engineer's expertise in optimizing data workflows, integrating diverse data sources, and leveraging cloud technologies to drive business efficiency and innovation.